Good afternoon, everyone, and thank you for coming back to this session on next generation security. My name is Myles Hosford. I'm one of the principal security architects here at AWS. And this session is going to be focusing on how you as financial institutions or regulated entities can move to the cloud in a secure and compliant way. So one of the things I want you to take away from this session is to have an understanding that when you move your workloads into AWS, you do have the option to be more secure than you are in a traditional on-premise data center, and also meet your compliance requirements from bodies like the Monetary Authority of Singapore. Now, I'm very lucky to be joined on stage today by James Wilkins, who leads the Cloud Task Force at the Associations of Banks of Singapore. James has been instrumental in the development of guidelines around the secure and safe adoption of public cloud for financial institutions here in Singapore. Now, before I hand over to James to talk about the ABS and where they are with the recent guidelines and latest developments, I just want to get started with something a bit closer to home with MAS and what they said almost 2 years ago now. So the picture on the screen there is from the MAS FinTech Festival in 2016. The gentleman on stage there is Ravi Menon, the managing director of MAS. And he said on stage that MAS has no objections to the use of cloud, provided that it is done in a risk-managed way and that financial institutions perform appropriate levels of due diligence. MAS in 2016 updated their outsourcing guidelines, so they refreshed them to kind of include the use of cloud and provide some guidelines to financial institutions. And the quote that you see on the page there is directly out of the outsourcing guidelines, and you can see that the MAS indicates that by using cloud service providers, you actually have access to quality system administration and uniform best practices that are already implemented by the cloud service provider. So some great messaging there coming out of the MAS. And I'm going to hand you over to James, who's going to get started with the ABS Cloud Implementation Guide. Thank you, James.
That's great. Thanks very much, Myles. So I think it's very interesting when you look at the journey that cloud has taken. That was actually quite a historic moment because 3-4 years ago, it was a very different picture. Everyone was approaching cloud as outsourcing, which it is, of course, in a way. And when you're looking at outsourcing, the guiding principle is your information security controls have to be as strong, right? So everybody wants to know when you're moving stuff to the cloud, is it secure? In fact, what we're finding now is that most of the security controls that we have in the cloud are stronger and more robust and more real-time than what we have on-prem. So, and also because cloud is no longer in the hype cycle, okay? It's heavily adopted. And what we're seeing is that when it's properly provisioned, it can really be a massive success story for security. So what I also think is when you are looking at cloud, right, it's not like when you get on an airplane. You're scanned once for security and then everything is okay. It's a constant journey. And you need to look at what I call the 3 Ds. So it's around due diligence. So that's before you go into the environment. Is everything safe? It's actually how are you protecting your data? Is it robust? And then disaster recovery, although disaster recovery is more actually about availability and resilience now. So let me tell you a little bit about the Cloud Implementation Guide. A couple of years ago, we had a business line come to me in my previous role as a country head of information security and say, hey, we want to do some testing in the cloud. And we were like, how are we going to go about doing that? And there were so many questions. People were nervous, there was conservatism. So we were like, okay, I actually sit on the Standing Committee for Cybersecurity for Singapore, which is a body run by the Association of Banks. And we started up the Cloud Task Force. And we sat down with companies like Amazon and said, okay, how can we make this work? What are the things that you need? What are the things that we need? What are the things that, at that time, the MAS need as well? So we brought together the triangle, the triumvirate to say, hey, this is important. We want to do this. It can change the game for the banks and for the security environment. So the first version of the guide actually really looked at a risk profile and materiality. For those of you that are familiar with the old outsourcing process of the MAS, everything hinged around materiality, and we wanted to clarify some of those difficult questions, such as, If there's customer data, does that automatically mean it's material? Do we have to have the right to audit on site? Do we, as the financial institution, have the right to come on site? So these types of things we wanted to actually understand better and provide a guidance. So it's more like a cookbook. And the version 1 was very focused on those day 0 and that day 1, ongoing governance. What is the relationship like with the vendor? What should it look like? What should the data center security look like? So I think the other thing that we also need to remember is that there's no such thing as cloud. It's actually just someone else's computer. So you need to remember that and make sure that you've come up with this concept of shared responsibility. And that was something that we really worked on in the first part of the guide, and it's something that we're going to continue to work on in the new version of the guide that hopefully will be coming out towards the end of this year. But the concept of shared responsibility is important because in the olden days, there was a saying, shared responsibility means no responsibility. And I remember my old COO coming up to me, and he was really upset about some system downtime. And he was like, I want one person's throat to choke, okay? That doesn't exist when you're in a relationship with a cloud service provider. You have to understand who's doing what. If you're using SaaS or you're using PaaS, who's responsible for each part of the stack? So that's really what it's about. The next version is really going to focus on things such as reference architectures, continuous assurance, and also what we're going to see is a focus now that cloud is no longer in its hype cycle and adoption is quite widespread. We're starting to want to look at things like MAS critical in the cloud, core banking in the cloud. How are we doing that? How can we do it safely and effectively in a way that makes sense for us as FIs and makes also sense for our customers, and in a way that the regulator is comfortable with, of course. So before I hand back over to Myles, I think this is a statement of the obvious, but it's actually where you have to start. Do your due diligence, the 3 Ds, due diligence, data protection, data resilience. Okay, over to you, Myles.
Yeah,
thank you,
James. Thank you very much.
You're welcome.
Thanks. So I think it's great the work that the ABS is doing here in Singapore to drive and further cloud adoption. And we really look forward to the released guidelines towards the end of the year that will really encourage financial institutions to approach core and critical workloads in a safe way. In this following session, we have John Austin and Sandra from DBS talking about core and critical workloads in the treasury markets business. So something to watch if you're sticking around. So something that James mentioned that really resonates and should really be front and center of your cloud security strategy is this concept of the shared responsibility model, or the shared security model. As James mentioned, when you move to a cloud service provider, there's going to be different levels of responsibility depending on the services that you consume. Now, as the cloud provider, AWS, we are responsible for what we call security of the cloud. And that really means things like the physical data centers, the global infrastructure, and any sort of software or API endpoints that you need to run and deploy your applications and services. Now, you as a customer and a financial institution, when you start to build applications, whether that's big data, digital banking, artificial intelligence, and machine learning, you're operating in the top half of that responsibility model, which is your responsibility, what we call in the cloud. Now, some items there will include things like your choice of operating system. So do you want Windows or do you want Linux? How you manage and patch those operating systems will still be controls fully managed by you and your organization. And also things like customer data protection. So when you move your data into AWS, we don't have visibility into what that data set is. It might be public data from your .com website, or it might be something really critical like your retail banking transactions or usernames and passwords, to your end users. Now, how you protect that data is controls that are fully responsible by you as financial institutions. We provide you native services like access control and encryption so you can implement strong security postures. But it's very important to remember that you're operating in a shared, responsible way. Now, one of the first questions customers ask me when I walk them through this responsibility model is how do we know that AWS is actually doing the right thing for us in that orange section or at the bottom? It's a very common question that comes up. So what we've done is really certify all of the controls that we have on the AWS side of the shared responsibility model against some of the world's most prominent certifications and alignments. So things like ISO 27001 for information security management, or PCI DSS for the processing and storage of credit card data. So we use independent third parties, and they regularly conduct independent audits, and we make these reports available to you as customers so you can perform your own due diligence. James mentioned how important it is to perform due diligence of vendors when you're selecting them for financial workloads. And if you really want to know about what we do on our side of the responsibility, you'll find them in these reports and artifacts that we make available to you. Now, last year, we launched a new service called AWS Artifact. You can go into the AWS console and self-service download these reports and artifacts. Now, if anyone in the room is part of a compliance team, internal audit, or maybe a technology risk function, you're really going to want to be looking at our compliance documentation to make sure that AWS's controls are aligned with the controls that you would expect. Now, on the screenshot there, you can see 2 examples of the artifacts that we have available. We have compliance reports like ISO 27001 and SOC 1 and 2. But we've also gone and mapped our existing control requirements to frameworks like the MAS TRM. So if you're familiar with the MAS Technology Risk Management Guidelines, it's a series of controls that you as a customer must ensure you implement to operate in accordance to the MAS guidelines. We've already mapped the requirements from a shared responsibility model to help you accelerate your usage and adoption of AWS. Now, when we talk about AWS security, there's a number of really core benefits that you get as a customer when you move into the platform. And the first one is this concept of inheriting our global security and compliance controls. And what we mean by that is I've already mentioned that we've got over 50 certifications and alignments. So controls like physical security or destruction of physical media when it becomes end of life. These are controls that AWS already does for you on your behalf, and we've already certified them with compliance frameworks. So from day one, when you move in into AWS as a customer, you benefit from these security controls right out of the gate. You don't have to worry about the physical security controls anymore, and anything on the AWS side of the responsibility model is already covered for you from a compliance perspective. Now, the second benefit is one that I really, really love. It's this idea of having visibility into your environment that you've never really had before. So let's take an example of a data center engineer visiting your data center. They probably sign into a book to visit the actual premises, and then let's say that they install a new server or a router. Now, the physical action of deploying that server and maybe the unplugging or plugging of network cables, none of that activity is typically logged or made available to auditors or any sort of teams that want to determine what changes have been made. Now, in AWS, because everything is available via an API call and everything can be logged using AWS CloudTrail, these logs can be saved indefinitely and made available to your audit teams, your regulators, or your cybersecurity teams to basically monitor everything that's happened in your environment over a period of time. So if we take the same example of someone making a network change or changing a firewall rule, you could essentially go back over a period of time and say, who made a change to my firewall rule on Monday at 2:33 in the afternoon? And where did they do that change from? And why were they authorized? What user permissions did they have? So you're going to get visibility into your environment that you just haven't been able to have before. Now, from a data protection perspective, customers always own your data when you move to AWS. So it's your data. You move it into AWS. You choose how it is stored, in which format. You can choose how it's encrypted. You can either use our native technology features to encrypt your data, or you can leverage some of your own technology solutions. You can also choose where that data is stored, and AWS commits to not moving that data around the world. So if you select Singapore as your region of choice to operate, AWS won't move your data to Europe, the US, or other countries in APAC. And that's on you as a responsibility to say, we require out-of-country resiliency so you can configure that data movement yourself. So from a security services perspective, AWS is one of the largest breadth, but also depth of services. Now, I'm not going to spend too much time going individually into each of these, but what I want you to notice is the number of services that we have in different categories of security, or different domains of security. So you can see there that we've grouped these into identity, detective controls, infrastructure security, data protection, and incident response. Majority of our security services are either free or extremely low cost. And we do this to make them accessible to all sorts of customers, Whether you're the biggest financial institution in the world or you're just getting started as a fintech, we believe you should have access to world-class security capabilities, which increases your security posture and reduces the chance of a compromise or a malicious attack. So before I dive into each of these individual services, I just want to give you a quick overview of each of these topics, and then I'm going to share kind of 4 next-generation security postures that our customers are implementing when they move to AWS. So from an identity and access management perspective, AWS provides a service called IAM. It allows you to create users and groups and roles, and you can define what those groups can do within your organization. So for example, you might have a DevOps group that allows your users to change the infrastructure, redeploy new applications. You might then also have a security group that allows your security engineers to make network changes or maybe change firewall rules, and those groups are actually segregated and independent from one another. We also provide very fine-grained access control. So from a permissions perspective, you have the ability to say, my development team are allowed to make changes on Monday to Friday between 9 and 5, and everything outside of that window is not permitted. So you can become very, very granular around changes within your business. We also support multi-factor authentication, and I've called that out really key there. It's so easy to enable in AWS. I would encourage you to kind of go, if you're already a user, speak to your AWS teams internally and just make sure that multi-factor authentication is enabled for your account. It's a very good security control, good security hygiene, so make sure that you have it enabled for your users that access AWS. So from a detective control perspective, I mentioned that we've got this service CloudTrail that monitors all of your API actions and activity within AWS. I'm going to come back to that in a moment. But something that I want to call out is a new service that we released in November called Guard Duty. Now, Guard Duty is an intelligent threat detection or a cyber threat intelligence service that monitors your EC2 instances or your servers. It monitors your DNS requests and your Amazon API activity. And it basically notifies you if we detect malicious activity within your environment, or if you've been compromised or you're currently under attack. Now, this sort of capability we've been developing over the last couple of years, and it provides you insight into your environment that is traditionally only afforded to some of the biggest companies in the world. So now, there's no configuration required, there's no appliances or host-based agents. Using Guard Duty, you can simply turn it on and start getting cyber threat intelligence from your environment. From an infrastructure security perspective, we have kind of everything that you would traditionally consider with infrastructure security. So we've got a stateful host-based firewall that we call security groups. They are mandatory, and you have to use them. And what we find by enforcing the use of these security groups is that you really get a segmented, like, micro-perimeter around your applications. Now, traditional infrastructure, people are very good at securing the north and the south, or what we would consider the perimeter of the infrastructure. But once you're inside the network, it's very difficult to stop lateral movement of attackers. So security groups are really good at doing that. What we also provide is a service called AWS Shield that sits in front of our entire AWS cloud infrastructure and protects our customers from DDoS attacks or the denial of service attacks on the internet. So if we detect a layer 3 or layer 4 DDoS attack against you as a customer, we can automatically mitigate that in real time, and you don't have to worry about that. Now, AWS Shield is free, as are our security groups or firewalls, and we can do this because we have such large investment into our security posture because we have millions of monthly customers on the platform. So data protection is obviously important to you as customers. You want to protect your customers' data once you move it into the cloud. It's front and center of any security discussions I have. In a moment, I'm going to come back to our main data protection service called KMS that allows you to encrypt your data. But I want to call out a service that typically is people don't know about, or I just want to draw your attention to Amazon's Certificate Manager. So if anybody is responsible for developing web applications, maybe mobile applications that are consumer-facing, you typically need to put a certificate on there. So you'll probably go to a registrar, pay for a certificate, and then there'll be some sort of manual process where you load that onto your web application server, and it sometimes can become a fiddly process. So Amazon Certificate Manager allows you to generate certificates, and you can automatically push those then to your consumer-facing endpoints, like your load balancers or like your CloudFront distribution. So this is very automated. The likelihood of a certificate expiring, which is a very common misconfiguration in on-premise infrastructure, is really reduced because of the way that Amazon Certificate Manager integrates with our wider ecosystem. Something that we've also done is basically innovate on behalf of our customers in the OpenSSL space, or TLS. So for those of you that are familiar with the vulnerabilities Heartbleed and Poodle that have come out over the last couple of years in OpenSSL implementations, Amazon analyzed the source code and realized that there was hundreds of thousands of lines of code that didn't really need to be in those libraries. So what we did is created a library called Signal to Noise, which is a very lightweight OpenSSL implementation that really removes the vulnerabilities or the overhead of these large-scale legacy libraries for TLS implementation. This is available on GitHub. You can download it and use it as part of your own application stacks. And a number of internal Amazon services use Signal to Noise rather than off-the-shelf OpenSSL libraries. The final domain that I want to talk about is this concept of automated real-time response. So from an incident response perspective, it's very important to react as quickly as you can when you know that you've been compromised. John Painter from Source did a great presentation earlier when he was talking about the ability to fire Lambda functions in response to changes in your environment. And this is really what we front and center of our incident response story. So in AWS, because everything is available via an API call, and the visibility that you have from services like CloudTrail, you can perform almost real-time response and fix or mitigate security misconfigurations before they've had a chance to kind of manifest in your environment. So John's example of auto-remediating a security group when someone opens up a vulnerable service to the internet, you can automatically close that firewall rule in around 30 to 40 seconds using some of this automated services, which is really game-changing from a cybersecurity perspective. Okay, so I want to share with you 4 kind of next-generation security postures that I'm working with financial institutions across the region with on a daily basis. So some of these examples are going to embody a number of different services, but I really want to get you thinking about some of the innovative things that you can do from a cybersecurity perspective. Yes, you're going to want to use a number of our different services to ensure that you have a foundational secure baseline, but I really want you to get thinking about some more innovative things that you can do that go over and beyond what you can traditionally do on-premise. So they're up on the screen there. I'm going to dive right in. So the first one is this idea of no SSH or no RDP for operations. Now, quick show of hands if any of you use SSH or RDP to log into servers. I would imagine everybody, okay? So it's very common. Everybody uses it. Now, some of the problems there are everybody shares usernames and passwords for production. You might use a vault to kind of check in your credentials, but typically the privileged users, the usernames are shared, like root and administrator, and very commonly the passwords are shared amongst multiple teams. Now, having SSH and RDP exposed is obviously increasing your attack surface, so what can we do about that? So we have a service called AWS Systems Manager, which is a host-based agent that you can install on your servers, both inside AWS, but also on-premise. So you can install this agent that covers your hybrid IT. And AWS Systems Manager does a whole host of tasks, but one of them that is really empowering is this idea of pushing commands down to the server without having to log into it. And this is the run command. So what you do is you install this agent on your servers, you ensure that you're covered across your entire IT infrastructure. Then if you want to actually execute a command like making a configuration change or maybe extracting a log file off the system, you log into AWS console, you access the Systems Manager panel, and then you can push the command down that you want. Now you can actually enforce only a set of commands if you want. So you don't have arbitrary access to production systems, something that MAS and other regulators are obviously very keen to ensure it doesn't happen. So you can actually define a set of scripts or a set of controls that are the only scripts and commands that can be executed in production. So you can log into the AWS console, select whichever command that you wish to be run, maybe restart your application server, maybe flush the development data, these common repetitive tasks. And when these commands are run, they are logged and monitored. So you can go back in a period of time and say, what commands were actually executed on my systems? Now, this is very difficult to do if you aren't leveraging automation and Amazon Web Services. The second kind of next-generation security posture I want to talk about is this idea of everything as code. Now, I'm sure you're familiar with things like infrastructure as code and application as code, but in AWS, because almost everything can be represented as API calls and scripted into code, you can start representing your entire infrastructure. So let's take an example. Most financial institutions here in Singapore will follow the MAS guidelines, the ABS guidelines. If you're processing credit card data, you probably have some requirements from PCI or your internal control requirements. Now, let's say that you've worked with all of your different internal stakeholders, like cybersecurity, IT audit, your application team, and your operations team, and you've designed this blueprint architecture that contains all of your controls around encryption, It contains all of your controls around IAM, login and monitoring, and everybody's really comfortable with that design. Now, what you don't want to do is have to recreate that design every time one of your development teams wants access to a development system or to deploy a new system in production. So what you can do is actually save your design essentially as code. We've got a service called CloudFormation, which allows you to define your infrastructure and all of the controls around it as basically block of text or JSON or YAML file. Now, that YAML file or CloudFormation template can be saved, and at any time, if your internal IT audit team wants to review it to determine what controls you have in place, they can simply look at this code and determine that you have these controls turned on. Now, one of the real empowering things about this is we have a service called Service Catalog that allows you to check in these reference architectures or check in these blueprints that allows your IT teams to redeploy these blueprints at any point in time that they want. So now instead of coming back to the cybersecurity team, once a week or every day and asking them to approve a design pattern, your end users or your business IT teams can basically automatically launch these blueprints from Service Catalog, and your cybersecurity team and your technology risk team knows that these blueprints are already approved because they've approved them, and then that will allow your business to be really agile and fast, deploy new services and move into production quicker, but while maintaining a really, really high bar on security. Now, a good use case here is you have the ability at runtime of these templates to change some parameters. So in my example there, I have an information classification rating. Now, for one project team, they might select highly confidential because they are storing maybe production data or critical data about your customers. And if you select highly confidential, the blueprint will detect that and actually deploy all of the controls that you need or that you've specified around protecting highly confidential data. Now, let's say someone had selected the environment as not production, but development. That might mean that you don't want a fully resilient architecture because you can cope with some downtime, or your RTO and your RPO of your application will be sufficient enough to support the downtime, so your development environment doesn't need to be highly available. So you can start altering your design at runtime, which is really empowering for end users. So this is a snippet of one of these blueprints, and this shows you here a firewall rule or security group inside AWS. And you can see there that it's meant to be for servers in the private subnet. So let's imagine that an engineer has started defining this. Now, as a security team or an IT compliance team, you have the ability to inspect these templates and actually identify vulnerabilities or misconfigurations before the environment is even deployed. So let's take a look here. We can see immediately that there are two vulnerabilities in this basically section of a firewall rule. The first one is that the rule is open to the internet. So anybody would essentially be able to log in or access the service. That's maybe undesirable for private servers. The other one is that there's a clear text protocol telnet there. Now, maybe that the operator wanted SSH, and then they pressed the wrong button, and now they've typed 23 instead of 22. And they may have opened up an insecure clear text protocol to the internet, but we have the ability to find this and detect it before it's even been built. Okay, so the third kind of use case I want to talk about is this idea of having encryption everywhere. So traditional IT, performing encryption can sometimes be difficult, complex, or really expensive. In AWS, we've created a service called KMS, or Key Management Service, that allows you to basically perform AES 256 symmetric key encryption across all of your servers and your storage when you use AWS. So you're going to be leveraging different services like S3 or EBS for block storage. You'll be using things like Redshift and some of our big data services. All of these services integrate directly with KMS. So you can encrypt your data very, very easily. What I mean by that is on the left-hand side of the screen, we have a screenshot of someone creating a volume, which would traditionally be attached to an operating system, so like a disk drive. On the right-hand side of the screen, we have someone creating a database. And you can see there, around halfway down on both of those screenshots, that the user of AWS has the ability to simply check a box or select from a drop-down, and AWS will go ahead and perform this encryption for them on their behalf. Really empowering, very easy to do, so it should not be any excuse not to have encryption across production, development, test. It's so simple and it's such an easy control to implement. Encryption at rest isn't the only part of the story, so you're going to have to think about encryption in transit. I've already mentioned that we have the service Amazon Certificate Manager that can help you push certificates to endpoints like CloudFront and CloudTrail. And then in a combination of using KMS, you can really design architectures that implement encryption everywhere. And when you combine this then with the CloudFormation blueprinting that I described, you can make sure that every time one of your internal IT users deploys a new system, encryption is already turned on by default for your organization. So very, very game-changing from the concept of having encryption everywhere, really low cost, without the complexity that would traditionally be associated with performing encryption at scale. Now, KMS integrates with our CloudTrail, our login service, and that, as I mentioned, provides you details like who decrypted the data. Now, if you try to think about that in your current landscape, do you have the ability to know who's actually accessed that data and who accessed the encryption key and put those both together to access the clear text or sensitive data? Now, because it's integrated with CloudTrail, you can have visibility into data movements around your organization and determine who's accessed the data, when it was decrypted, where did they decrypt it from, and you can store that for your auditors, for your regulators, and even for incident response if something bad does happen at some point in time. Okay, so one of the final things I want to talk about is this idea of automating compliance. And I think you've heard about it a couple of times today. I know a couple of the other presentations have covered this. But this is really game-changing from a security perspective on how you, first of all, become compliant, but secondly, demonstrate that you are compliant. So if you're a financial institution, you probably follow the MAS TRM. You will be following the MAS outsourcing guidelines, and you will be leveraging the great work that the ABS is doing by recommending these key controls that you should implement. Now, I'm sure most of you are familiar with this spreadsheet. This is the MAS TRM that the MAS publishes. And you as financial institutions are expected to basically ensure that you are compliant or you are performing risk management in line with the recommendations from MAS. Now, traditional compliance frameworks operate in a way where the technology risk team will send this spreadsheet to the development teams or communities, and the development communities will try to determine if they are compliant on a best effort basis. So they will go and look for some evidence, they maybe will take screenshots, but ultimately they will mark the spreadsheet as green or red and send it back to you, and that's kind of the process over. Now, I'm sure there's a number of you in the audience that are very familiar with spreadsheets and Word documents for determining compliance. But some of the problems with that is it's very difficult to ensure that you're actually compliant or the person that's filled it in actually knows the answers. So you're assuming that the person that you've sent it to really, really knows if you have these controls turned on, and then they need to go basically and demonstrate that compliance back to you. Very difficult to do if you're not leveraging automation and APIs. So what we've done at AWS is create a service called Config Rules, which allows you to codify all of your technology security requirements, and these security controls run in real time inside your environment. So let's take an example where you want to ensure that you use encryption. So first of all, you should be using AWS Identity and Access Management to ensure that your users have to launch encrypted servers in the first place. You could combine that with our CloudFormation template in blueprinting service that allows you to ensure that your developers are launching from approved patterns. But let's say that there's an edge case where someone does create a resource that doesn't have encryption. Now, in real time, AWS config rules will run, or near real time, and determine if any of your resources aren't compliant with the controls that you've specified. So you can pair these controls up with the MAS TRM, you can align them to other regional regulatory frameworks, and in near real time, you will have visibility into your environment and be able to know if you are compliant or not with accuracy. So if any of your resources are changed, maybe by someone accidentally, or maybe someone doesn't know that they needed to use encryption, for example, maybe a new joiner, AWS will show you instantly that this has happened. Now let's take a look at an example. Let's say a user launches a server and they don't select encryption. AWS config rules will review that change in near real time and then allow you the ability to specify what the action you want to take is. So you can either do nothing and just list it as non-compliant on the dashboard, or you can write the response function, as John mentioned earlier, these Lambda functions that automatically respond and fix things. So you're basically creating a self-healing environment that the moment something goes wrong, or the moment a change happens that shouldn't have, AWS config rules can auto-mitigate or auto-fix this. So this is game-changing from a perspective of ensuring that you are always compliant. Now, the two examples I have there are just examples. The first one, you might say, okay, we've determined that a server is not encrypted. Let's go ahead behind the scenes and perform a snapshot, turn on encryption, and then redeploy the new encrypted image. You could do that. Or what you could also do, that a number of my customers are, is actually terminate the server straight away. So if someone's just launched a new server without encryption, 30 seconds later it's shut down. And then an email is automatically sent to the developer or the operations staff that says, hi, this is an automated email. You are not compliant with section 11.4 of the MAS TRM. Please try again, with a link to a wiki page that says, what they should do and how to achieve that inside your organization. Now, what you've done there is detect the security misconfiguration. You've automatically fixed it or mitigated it by shutting it down, and there's been no human intervention. So your technology risk team can focus on actually managing technology risk. Your cybersecurity team can focus on real cybersecurity threats to their business, and all of this low-hanging fruit around just making sure you are compliant can be automatically managed by services like Config and the automation services that we have. Now, another feature of AWS Config is the ability to drill down into these compliance requirements and see a change history over time. Now, I'm sure many of you are familiar with regulatory inspections when the regulator turns up on Monday and all of the bad issues get fixed over the weekend. If anybody's familiar with that, quick show of your hands. Nobody wants to admit, a couple of you, yeah. But using the AWS config, you can go back in time and see when resources were compliant or when they became compliant or not compliant. So if a server today is encrypted, you can use AWS config rules and say, was it encrypted yesterday? Was it encrypted last week? When were these changes made? By who? And what has the status of my compliance been over a period of time? Really, really empowering for technology risk teams. So I'll give you a very quick overview of the services that we have, and also hopefully an idea of some of the next generation security postures our customers are using. Where do you get started? So first of all, we've developed a number of user guides for financial services across APAC. We've created an MAS user guide that specifically focuses on the outsourcing guidelines, the TRM, and also the ABS key controls. We've done the same for Hong Kong, Australia, and India, and you can find these there on the website. If you follow those links, that'll take you there. There's also the link to the financial services section. We've also partnered locally in the region with companies like Accenture, who have developed their own user guides around implementation of the MAS key controls on top of AWS. And if you go to their site, you'll find a user guide specifically tailored on MAS implementation via Accenture. So from an actual implementation perspective, we've got a program called the Well-Architected Framework. And what this is a body of knowledge that we've built up over the last number of years that really instills all of our best practices from a number of different topics, like security, cost optimization, operational excellence, and resiliency. And that allows you to basically measure yourself and your application deployments against what we recommend as best practices and ensure that anything that's deployed to AWS follows these design principles. Now, security is just one pillar, as I mentioned, but the security-specific design principles are listed there on the page, on the slide. You can visit our website and download this security well-architected framework, which gives you prescriptive advice and guidance on what you should be doing. So these are just the high-level principles. We drill down a lot into what we would recommend you do. So I want to close with this quote to conclude. Hopefully from this session, you've seen that we have a very broad and deep range of native security services. Something I didn't cover is our partner ecosystem. So if you don't want to use native security services and you're more familiar with things that are available in the marketplace, I would encourage you to take a look at that and bring those into the cloud on your journey with you. But what Gartner says is that CIOs and CISOs really need to stop obsessing over these cloud security worries, like, is the cloud security provider safe? Is the cloud security provider doing the right thing? And instead, channel your energy into these new innovative approaches to security. So leverage some of our services like Lambda and Config and start automating things in real time. And I think if you start channeling your energy and focusing on security and what you can do, you'll start having a really good security posture, and hopefully you'll see that you can be more secure in the cloud than you can do in an on-premise infrastructure. So with that, I thank you, and I hope you enjoy the rest of the day.